Back again to talk about the scientific method. So we just finished up with naturalistic observation, and that is a type of descriptive research. And now we're going to look at the second type of descriptive research called the case study method. And this is where we would do an intensive, in-depth investigation of an individual or a small group of individuals. So to study one individual or group in depth gives us the potential of revealing things that are true about everyone. So, this technique is used to investigate rare, unusual, or extreme events or conditions or phenomenon. They can provide information that can be useful to help us understand normal behavior. So, we have four uses of a case study. It can be the source of insights and ideas. For example, Freud's theory of psychoanalysis emerged from his case studies of his therapy clients. Number two, it can be used to describe rare phenomenon. So scientists studied a woman who remembered everything that has ever happened to her, and this allowed us to shine light on how memory functions in the rest of us. Number three, the case study is used in psychobiographies. So we're going to use psychological concepts in an effort to understand famous people. So you might have read a psychobiography, for example, on Hitler. Number four, case studies are used to illustrate general concepts and give examples of general concepts. So, for example, Erik Erikson developed a theory of human development, and he would use case studies to illustrate the stages in his theory. So, we have some limits to case studies, however. They are virtually useless in providing evidence to test behavioral theories or treatments because no matter how reasonable a researcher's explanation is in explaining why they observe a certain pattern of behavior, alternative explanations cannot be ruled out because the study was not completed in a controlled laboratory environment. So none of the variables have been controlled in this type of research. Number two, most case studies rely on observations that are completed by a single investigator or maybe just a couple of investigators. And so there's no way to assess the reliability or the validity of this researcher's interpretations. So the researcher may have a vested interest in the outcome of their study, and the research may be pervasive with significant bias. So let's look at a third type of descriptive research, and that's going to be the survey. So a survey is designed to investigate the opinions, behaviors, or characteristics of a particular group. And remember, a survey is usually a self-report format. So we're asking an individual their opinion about things. So surveys allow researchers to gather quite a bit of information from a large group of people. And one of the benefits is that we can gather lots of data very quickly with the survey method. One of the ways that researchers try to control for the bias of trying to please the researcher or the bias of dishonesty, for example, in answers is they might repeat the same questions at different points in the survey. They also might repeat the question in a negative format if they've initially stated in the positive. So for example, survey question might be, I like ice cream. And then it might be repeated later where it says, I don't like ice cream. And so the respondent is going to need to answer consistently there. And that's how we tease out sort of dishonest answers in the survey. So remember, the benefits of surveys, they're cheap, they're fast, we get lots of data. Some of the cons of surveys is that we can get a lack of truthfulness in the answers. we can get demand characteristics. And what I mean by demand characteristics is that's where the respondent is going to try to answer the survey to please the researcher. In other words, they know what the researcher is trying to get at, and they might want to skew their answers in that way. We also might have wording effects. In other words, some of the questions in a survey might be leading or not appropriately worded or misleading and impact the results. Now let's look at pseudoscience. Pseudoscience promotes claims in a way that appears to be scientific and plausible, even though there is not sufficient supporting empirical evidence. So your textbook talks about magnet therapy as a great example of pseudoscience. So you may have been to the mall and seen the kiosk for those magnet bracelets, and the person who sells these oftentimes has very outlandish claims about what these magnets can do. They can cure anything from seizures to arthritis to ADD. The problem with pseudoscience is that it's based mostly on testimonials, jargon, unfounded, irrefutable claims, and multiple outs. In other words, if you buy an expensive magnet bracelet and it doesn't work, you might come back and the person who sells it might say, well, the magnet acts differently on the different parts of the body, so they're going to give multiple outs. Another out they might give is that the magnet was placed on the wrong spot on your body. Another out they might give is that everyone's body will respond differently to magnets. They might say magnets were the wrong size or the wrong type or shape, and so therefore you need to buy another magnet, maybe a more expensive one, maybe one that's stronger. They might say the magnets weren't long enough, etc. So you know what I'm getting at. Pseudoscience is not empirically supported. No empirical evidence. Now let's look at correlation. So correlation is how we're going to look at the relationship between variables and how we're going to make predictions about that relationship. So the example that I'm giving you on this slide is that we're going to have two variables in a hypothetical study. We're going to measure the parents' disciplinary style. In other words, how do they discipline their child? Are they more democratic in the way they discipline their child? In other words, they allow two-way conversation between the parent and child? Or are they going to be more authoritarian in how they discipline the child? That would be more of a military style, where the parent might say, hey, it's my way or the highway, no talking back. Okay? And then a scientist might want to measure the disciplinary style as it relates to child's behavior. So we're going to see if there's a correlation between these two variables. Remember that correlation does not prove causation. So if we see that there's a positive relationship between parents who are more democratic in their parenting style and how well the children behave, how well adjusted the children are, for example, we cannot say that it was the parenting that caused the child to behave that way, because we have not controlled all of the variables in this study. We've just pulled out two variables and we're seeing how they relate to one another. So it's possible that democratic parents produce better behaved children, but it's also possible that children who behave very well encourage parents to give their children more leeway and encourage the parents to become more democratic, for example. So there may be an unmeasured factor here. Good neighborhoods produce democratic adults and well-behaved children, so maybe it's the neighborhood that is the impeding variable. What we also know about children as related to their parents is that genes account for 23% of the variability in how children are parented. So this is another variable that impacts that relationship. So when you read research in which a correlation has been established, the correlation is going to be reported to you in the format of a correlation coefficient. And this is a number between -1 to 1. And this number indicates the strength and the direction of the relationship between two variables. So, when we determine the strength of the relationship, in other words, how closely related are two variables, we're going to look at the raw number. So you're going to take your finger and put it over the sign. It doesn't matter if it's a negative or a positive when we look at the strength of the relationship. The closer the number is to 1, the stronger the relationship between the two variables is. In other words, the more one thing changes, the more the other thing changes, okay? That's where you're looking at the raw number. Now, for the second part of that coefficient of correlation, you want to know the direction, the type of relationship. In other words, do two variables change in the same direction, or do they change in opposite directions? And that's where you're going to look at the sign. So if it's a +1, that means two variables have a positive correlation. Okay? And a positive correlation simply means that two variables change in the same direction. Okay? Here's an example of a positive correlation. Studying is positively correlated with good grades. Okay, so the more you study, the better your grades are. Driving speed is positively correlated with gas consumption, for example. So those are two variables that change in the same direction. Let's look at negative correlation. So when you see a negative sign in front of the number, that means two variables change in opposite directions. Here's an example of a negative correlation. Partying is negatively correlated with grades. So as partying increases, grades go down. Okay. So my question for you is, what type of a correlation is this? I'm going to give you an example. The less someone sleeps, the lower their grades. Is this a positive correlation or a negative correlation? Think about how these variables change. Do they change in the same direction? Do they go up together? Do they go down together? Or does one variable go up and one variable go down? In this case, both of the variables go down. The less someone sleeps, the lower their grades are. So this would be a positive correlation because the two variables change in the same direction. Which is the strongest correlation? Remember, a correlation coefficient is any number between negative and +1. So 1.1 is not a correlation. If you see this reported in research, that means the statistician made an error in their calculation. So rule that one out. Next, to determine the strongest correlation, you're going to look at the raw number. So put your finger over the sign. And what's the highest number? That's right, it would be 0.95, so that's the strongest correlation. This is where we're going to end for part 2 of the scientific method. Take a few moments to review your notes before we finish up with part 3.